Yeah. Hello, everyone. Welcome to this webinar. We'll wait for another minute or so for everyone to dial in, and then we can start with the presentation. Okay, cool. So welcome again. So in this webinar, I'll take you through the modern customer graph that we have built at Lifesight. We will go through at a very broad angle on what our tech journey has been so far and how it culminated to the customer graph that we have built to solve a lot of ID unification, ID resolution, and enrichment use cases. So before we start, if you have any questions at any point, feel free to drop your questions in the Q&A section. If time permits, towards the end of it, we'll go through the questions. We will try to answer as many questions as possible. But if we are unable to answer it due to time constraints, we'll be publishing a Q&A blog where we will get back with detailed explanations for every question that you have. Moving on. So before we start with the webinar, I thought I'll introduce myself. So I'm head of products at Lifesight. I work closely with both our product vertical and also our tech teams. In the product side, I contribute towards product strategy, manage product roadmap, etc. And in the technology side, I manage our technology programs, innovations, and other such initiatives. So before we dive deep into the technology and other such specifications of the graph database, I'll try to sort of explain what were our primary motivations in coming up with graph DB and ID unification capabilities. So Lifesight is known for some of the initial products that we launched in the market in terms of Lifesight attribution audiences. So when we were building and scaling these products, there were some very specific ID related challenges that we were facing, right? Especially when we were doing cross device measurements, when we were building audiences and preparing data for cross device activations, etc. So we started looking into these problems and trying to started brainstorming about these things that we were facing and were conceptualizing solutions and building products that sort of solves this problem. When we were at it, we found that there are a lot of synergies between what we were trying to do at Lifesight and what are the key challenges that modern day marketer faces with data in the real world out in the market. So you have a lot of questions here, right? A lot of hows essentially on how you can understand your customers, how you can measure the return on ad spend, how you can optimize your campaigns, etc. So in principle, all these questions can be answered accurately using data, right? And there's no dearth of data. So let's pick one example. If you need to measure the campaign from conversion perspective. So essentially what you have to do is you have to bring two types of data together. You'll have your ad engagement data, which originates in the DSP where you run your ad, and you have transaction data or some sort of conversion data, which originates either on your website or in app or in stores, etc. So if you can bring this data together, right, it will help you answer a lot of questions. So non-availability of data is not the problem, or it's not what sort of makes these questions difficult to answer. What makes these questions difficult is the nature of the data, where it originates, what's the type of the data, and what's the quality of the data, right? So these are some of the things that makes these problems complicated. And adding on to that, the ecosystem in which we operate disruption happens every time. So a methodology that you can use today to sort of bring your data together, to just give you one example, to third-party cookies, might not be a valid method, say, a couple of years down the line, right? So there are other challenges in the ecosystem which sort of makes these problems even more harder to solve in long term. So what Lifesight found out was the things that we were trying to solve internally can be the capabilities that we built internally can be leveraged by other marketers through various RESTful APIs, etc., or through our platform itself to answer some of these questions with a very high degree of accuracy. Before we get into more technical stuff about our customer graph, let me define what a graph, what a customer graph is. So from technology perspective, there are very precise definitions on what a graph is, right? It's a data structure. It's a simple data structure and also very powerful. And you can model a lot of real world problems where there are entities and relationships between these entities in a graph database. And it makes traversing through various entities and to run queries based on these relationships a lot easier. So there are precise definitions on what a graph is in the technology world. Now we are using this technology to solve some of the business cases. So at that point, the definition becomes slightly fluid, right? From a business perspective or from a product perspective, you are sort of trying to define this in a more business way. So when we talk about a customer graph, it's a dynamic graph, right, which gets updated very frequently, where we upload a lot of second and third party data that we source from a lot of places, and where we sort of quantify how various entities sort of talk to each other and relate to each other in a lot frequently and keeps them updated, so that you can then build a lot of services on top of this identity graph. So when we started thinking about the graph data, there was the central idea of a life ID, right, which we wanted to impose onto the graph database that we are building. And we also adopted certain first principles, certain non-negotiable first principles on what a life ID should be. And it was these first principles that later became foundations to when we started designing the graph DB and when we started implementing some of the processes around how we update the database. So we have those first principles listed here. Life ID was supposed to sort of quantify and establish relationships between identifiers. Establishing relationship was one angle, but we were also very particular that because given that the data is originating from a lot of disparate sources, it's very important that you have to quantify the quality of the relationships using multiple attributes, right? You need to score it for its recency, its frequency, and also you have to score it for whether it has originated from a deterministic source or a probabilistic source. So Life ID's first couple of principles were to establish relationships and second to quantify them. Third principle was to sort of conceptualize this whole graph in such a way that consent management and data privacy is central to this. So we'll be diving deep into this point in some of our subsequent slides on how you can have very broad opt-out mechanism at scale using some of the graph concepts. Life ID is also conceptualized to work in a future world where cookies does not exist and where some of the IDs that are very relevant today are perhaps sparse, right? So we wanted to have a framework that is that will stay relevant even in a world where there are new IDs that has come up, and in a world where some of the IDs that are taken for granted today do not exist. And last, but one of the most important aspect of a Life ID is that it has to be persistent. So a lot of technology Life ID is persistent. And again, we'll touch upon all these first principles. in fact, would revisit all this principle at different stages of these presentations as we move along. To put graph database into context, we thought it's better to give you a high-level picture about what our tech stack is at Lifesight. So we have built our front end in React using React.js. Our business logic is primarily written in Java. Our infra is in Google Cloud Platform. We run a lot of Spark jobs in Dataproc for big data processing. We handle a lot of streaming data. Excuse me, a lot of streaming data. For that, we leverage Google's PubSub. There are a number of data stores that we use across the board to support various use cases. Elasticsearch and Bigtable are a couple of very prominent data stores that we have. For relational databases, we use MySQL and Postgres. Postgres is specifically used to manage our cases database because it gives some state-of-the-art JS capabilities through its Postgres extension. And Elasticsearch and Bigtable is used for a lot of our real-time querying, for a lot of other reporting purposes, and a platform directly reads some of these databases. We also have Lucene Index, which is used for geospatial resolution. So this was our tech stack, a sort of a very, very simplified view of various technologies that we use in our platform to support our modules. So we also have certain key performance results that we have achieved over the last couple of years, right? So our Spark jobs in an iteration has to crunch through 40 terabytes of data to support our measurements and audiences. PubSub handles billions of events. Lucene Index helps us to resolve tens of billions of mobility events to our geospatial resolution of mobility events on our places data. And we have Elasticsearch clusters that are terabytes in sizes and where there are indexes, each of which are, say, a few hundred GB. And we run real-time APIs on top of these indices, Elasticsearch indices, to support a lot of our use cases. So one takeaway from this particular slide was even before we sort of onboarded on our graph database journey, we had set ourselves some very high benchmarks, some very high standards on what are the key performance metrics that we should achieve, right, when we onboard a new technology to solve some of our other problems. Honestly, at this stage, we were a bit smug about what we were able to do with all of this, but it posed some very specific challenges when we started brainstorming about a customer graph. Because when we talk about customer graph, we're talking about networks, we're talking about clusters, we're talking about nodes and relationships. And it becomes slightly difficult for you to sort of model all of that into a non-structured database or to a relational database. But we did try that. So when we initially thought of having a customer graph, because we had a very stable and a scalable system which was already built on top of Elasticsearch and Bigtable, we explored a few ways in which we tried to model a graph database on top of Bigtable. Right? So we used GraphX in Spark and ran some very complicated connected components logic and simulated a GraphDB on top of Bigtable. To some extent, it sort of solved some of the initial problems that we had. It gave us good performance. But when it comes to managing and scaling this to new IDs, new types of IDs and more data, it became quite unmanageable for us to do that in this particular arrangement. So when we were onboarding a new type of ID, right? For example, when we were onboarding perhaps a different type of hashes of mobile numbers in a particular market for the first time, it sort of exponentially increases the complexity because we have to manage too many big tables. It exponentially increased the complexity of a components logic, connected components logic, which we were deploying through Spark. And things weren't scaling up the way we thought it would. And most importantly, going back to our one of the first principles of Life ID has to be persistent, right? So rerunning the connected components logic multiple times meant that we had to discard a lot of Life IDs and replace them with new ones. There were a lot of logical challenges in this way of deploying a graph database on top of non-graph data structure. That's when we started exploring graph databases specifically so as to onboard our consumer graph to them. We started with Neo4j. We spent a couple of months and run very extensive POCs on Neo4j. There were certain things because of which we were not very comfortable. Point number one was we had to keep all our data in one node. To sort of work around that, we decided to partition our data to different chunks and create multiple clusters to manage this. And thereby we were creating artificial data silos. So we were essentially trying to solve for data silos through a graph database. But because of certain restrictions in Neo4j, we were not able to achieve that at scale. And also there were certain cost-related concerns. And also we were not able to get the kind of write performance. Read performance was decent. We were not able to get the kind of write performance that we were looking for. Then we moved to JNS Graph. Certain aspects of JNS Graph appealed to us instantly. For one thing, it had this pluggable storage backend architecture, right? So we already had all our data kept at multiple data stores, and it was already consumed by some of the third parties through our APIs and also by our platforms. JNS Graph gave us the opportunity to plug them to JNS Graph. JNS Graph does not have a native data storage, so it gave us an opportunity to plug these data stores to JNS Graph. So there was a logical extension in our journey, right? How we can onboard our data to a graph database. And it was easily scalable. It was suitable for analytical data, which is aggregated data, and also for transactional data. It was open source, and the licensing cost wasn't there. And we found that it was 10 times cheaper than licensing for some of the other graphs. We got extremely high read performance. We got better write performance, and there were also ways to improve write performance because you need not write on the graph. You can write on some of the underlying data stores and then consume them in the graph. So overall, we were very happy with the results that we saw. It was in line with the performance that you're seeing with our other databases, and the APIs that we tested on top of JNS Graph was giving the kind of RTP scale that we always aspire for whenever we make a service. And we decided to go with JNS Graph. So how does it work? So I'll come back to this slide in a while. So I think we'll use this diagram, which is a diagrammatical representation of whatever we have written in the other slide. So how does this work, right? So when we think about data at Lifesight, at a very high level, there are two types of data. One type of data is very dynamic. It is transactional in nature. These are data that flows to our system on a regular basis every day. And in terms of volume also, the size of this data is higher than the second type of data, which is static data. So when it comes to static data, it doesn't mean the data is not changing there, but the frequency of change or the volume of daily change is far lesser than this dynamical data set. So what we do is we bring all this data together and we build what we internally refer to as master data. And there are 4 types of master data that we build today. There is mobility master data, app event master data, web event master data, and transactional master data. And when we build this master data, there are very advanced algorithms that goes into each of these processes. Some of these algorithms were built over a period of 2.5 years, sort of capturing all the learnings that we have had in working with geospatial data and working with app events data, etc. There are a lot of anomaly removal methodologies. There are a lot of other logic which is sort of baked into the way we build master data. Once the master data is run, what we have is a clean data set which can be then consumed across the board in our other products. As an output of this master data, we have identity master data feed and attribute master data feed. These feeds are then used to update our graph nodes and are then used to sort of manage the relationship between various nodes in the graph database. We have then built some services which sort of runs on top of this graph database. And these services are used extensively in-house by us in some of our products. And we also have a few third-party clients who uses these services elsewhere for ID resolution, enrichment, so on. There are a few services which is not listed here, which we consume it internally, and also we plan to make them available to third parties. There are RESTful APIs which helps you to do A/B testing. There are RESTful APIs which enables you to do lib studies, right? Which your data, leveraging our ID unification resolution capability to take out data that are collect, etc. So this picture at a very high level captures all our needs, and so apologies, just give me a minute. I think something happened with the screen sharing. Okay, is it? Okay, good. Apologies for that. So we were talking about how we solve it at scale. Moving on to the specific of how the data is modeled in itself. So as I was explaining earlier, graph data structure is very simple if you think about it. It has nodes and it has edges, right? And nodes are entities, and edges sort of quantifies how these nodes are related to each other. You can have directed graph or undirected graph. Directed graphs are used when you need to establish a hierarchy between nodes. Undirected graphs are used when a hierarchy is not needed. So the way we have conceptualized the graph database is every ID is a node. So an email is a node, a hash of an email is a node, hash of a mobile number is a node, mobile ad IDs and hashes of mobile ad IDs are nodes. So all of these are nodes. And from various data signals that we source from a lot of other places, we establish relationship between these nodes. So whenever we establish a relationship, we quantify the relationship. So how frequent is that particular relationship seen? What's the recency of that relationship? Based on the source from which the relationship is originates, we are able to score it, and we are able to score that relationship, whether it is probabilistic, whether it is deterministic. Internally, we call this strength of relationship, and we are able to score the relationship. And most importantly, once we have these clusters, right? So the output of all of this is a lot of disconnected clusters. Once we have this cluster, every cluster is assigned with a life ID. So life ID identifies the cluster to be an individual or a household. This is better explained in this particular diagram, right? So you see a lot of red nodes here. So these red nodes are identifiers that we collect from a lot of places. Blue nodes are life IDs, which are artificially assigned to every node, which meet certain threshold of quality in terms of recency, frequency, and strength that they can be, by which we sort of infer that they can be grouped to an individual. Once you have individual profiles identified in terms of cluster, we try to establish relationship between life IDs itself. Because if you can establish relationship between life IDs, that would essentially help you to make a bigger cluster of profiles, which is potentially the household that they are part of. So when two life IDs are joined, what you have is a bigger cluster, and that's the household to which the individual profiles belong. And the relationship between two life IDs are slightly more complicated than relationship between any other node. Because here we essentially capture a lot of geographical information, IP-related information, etc., so that we are able to quantify with a higher degree of accuracy about the household itself, right? No. Uh, and we have given an example here on what are the properties of a node or what are the properties of an edge. Uh, Moving on, this slide essentially summarizes what we have achieved right with this graph database. How are we different? How are we special? As we speak, the graph DB already has 5 billion nodes and over 7 billion relationships. And we have already built RESTful APIs on top of terabytes of data, which helps us to do ID unification, resolution, and enrichment at scale. And we always aspire for the RTB scale so that these services can be used by third-party platforms, can be used by other CDPs, CAPs, other apps, etc., to leverage some of the capabilities that we have solved here. So while talking about scale, we have not compromised on the quality. Most importantly, we have quantified the quality of relationships. So when we say that these IDs are grouped together to form an individual profile, we assign the score to that particular set of relationship, to that cluster. And we are very transparent about this as well, right? So when we say that these devices are grouped to a household level, we give out scores, which, and also essentially being very transparent about the logic that has gone into it on how we quantify these relationships. And that is, again, going back to the first principles of life ID, that is one of the key things that we have sort of planned for and managed to achieve through Life ID. And last one, and one of the most important thing, is on how we have sort of baked consent management to this whole system, and how it's managed seamlessly, and how it's centralized in the way the graph is designed. So we have, again, RESTful services which we consume internally, and also we give our customers to use if we need to opt out their data in our platform. If those opt-out requests are fired by passing various IDs, it helps us to remove the profiles at scale, right? So it's not only about suppressing the data, we remove the records, and you can do it at scale. So for example, if a customer decides to opt out based on a hash of an email, right, we are not only opting out that ID, essentially removing that entire profile. Right, so we have sort of taken the whole idea of data privacy and consent very seriously, and the consent management framework is built in such a way that you can remove the entire profiles at a time. Right, so that sort of brings us to the end of this presentation. Yeah, and just to sort of summarize, we have sort of touched upon some of the technical aspects, deep dived into how we have modeled our data. Also, I believe that we have added some business and product perspectives as well. We'll be writing a blog and getting back with detailed explanations for all the questions that you have posted in the Q&A section. And I'll also take a moment to thank. So I've been just been the spokesperson of our tech team, who has sort of pulled this off in a quick time, where we had to build a very scalable consumer graph on top of the data that we have, which grows in terabytes, which sort of multiplies in scale every month. So I would also take a moment to thank the team for building this. So thank you everyone for taking your time out and joining this webinar. And we will get back to your questions through our Q&A blog. Thank you.